All right, let's make a little more silliness here. All right, there were some of these that were just sort of silly, 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 silly. Please, please, please. And I remember marking ones wrong. It was because of this. Are either of those two things exponents? No. It's like pre-algebra, 8th grade, 7th grade, 6th grade, just 12 over negative 6. It's negative 2 over 1. You can make it a negative 2 over 1. You can make it a 2 over negative 1. You could put the negative out front of the 2. I'm just going to suggest making that a negative 2 like that. And that is done. That's not going anywhere. That's done, that's done, that's done. All sorts of ways you can attack this problem. I'm going to choose this. I'm just going to put together my x's on top and keep them there for a while, add the 4 and the 1. As long as I'm at it, I'm going to bring down that y to the negative 8. So this 12 over 6 is all done with. We're not even looking at that anymore. Still have an x to the 3rd here. I guess I was bringing this y to the 8th down. Z to the 0, everything to the 0 is a regular 1. And this y to the 10th is down there, and I got to make sure I did things right. X to the 5th that stayed on top. Y to the 8th that moved down low. X to the 3rd, y to the 10th, they stayed there. All right. Think of the rule, subtract 5 minus 3, or think of this way, there's 5 of them here, there's 3 of them here. There are 2 that remain on top. 8 down there, 10, there's 18 down there. All right. So then there's our ones like that. Okay, I'm going to get to the radical simplify now. Those are like the square root signs. That's what we're heading to now, the square root signs. All right. Josh, it's okay to be tired. Just turn around, look back there, and you're just going to go, hello. It's like going to be, you're just going to wake up. It's as if spring has arrived, or else construction season. Yes. What you two need to do is like go outside and just, wave people in, wave stuff. Do you have the same pants on too? Okay, all right. Still so fun. All right, somebody asked me, it might have been one of you. Somebody asked me, are these going to be written down anywhere? Or do we have to memorize them? The answer is no and no. All right? There's going to be some cube roots. Well, do you have to memorize them? No, but you could just figure them out. 2 times 2 times 2. Oh, that one's going to be 8. All right, there's going to be some cube roots. 3 times 3 times 3. 4 times 4 times 4. So, are they going to be written down for you? No. Do you have to memorize them? No. There's going to be some 4th roots. Maybe. All right, well, just figure it out. 2 times 2 times 2 times 2 will be 16. 3 times 3 times 3 times 3 is going to be 81. There might be some 5th roots. Figure them out. All right, so how about I go over here? That one's locked. Do you feel that I do more on that side, and do you feel that you have been less than you do? Okay. All right. Say, I should use, we're getting new somethings next year. We're getting new TV, smart TV. These are done. And I can put my new smart TV anywhere. I was thinking here. Would that be sort of neat? Oh, big whiteboard. Girls. Well, hi. Hi. All right. Does that pass mean you can leave like 30 minutes early anytime you need to?
Yeah.
Good, 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 good. Oh, no, you just keep it. Don't approach. Don't approach the front. Okay. Oh, this is fun. Hey, are you awake yet? Just look back there. Whoa, hello. Oh, my goodness. This is exciting. I wish I could record to the recording people what just happened. Hi. All right. With no fancy calculator buttons whatsoever, I'm going to say, with no fancy calculator buttons being used, we're going to look at that. Well, 2 times 2 times 2 is 8. You could go 40 divided by 8 and see if it goes in. It goes in evenly. The first step is people keep their hats on. The reason I did 8 is it was 2 times 2 times 2. Cool, then I say, would you please take your hat off? And the cube root of 8 says, yes, I will, sir. The cube root of 5 is an obstinate little jerk and says, no. If your calculator has fancy functions that actually do that, then please use that. Whoa. Do not use that. If you've got a calculator that just does that, you are not allowed to do that. Said that one wrong. Okay. Now we're going to get a few of these, then there are letters in there. They're called variables. I suggest enjoying the x's, y's, and z's all separately and the number separately. So we're at a cubed root on the other board that the at-home players can't see. 2 times 2 times 2 is 8. So again, I can break this one into 8 and 10. In just a short moment, that cube root of 8 is going to take its hat off. Can you actually see? You can still see that. All right, cool. Now I suggest going to the fraction method and make it x to the 7 over 3. 7 over 3. Make it y to the 10 over 3. And make it z to the 15 over 3. All right, well, things are going to get done at a different time. 8 gets done. All right, to refresh your mind on the variables. We lower these fractions to the next lowest fraction that's a whole number. 7/3 is not a whole number, but 6/3 is a whole number. So make this into 6/3 and 1/3. 10/3 is not a whole number, but 9/3 is. So we're going to go to the 9/3 and the 1/3. And 15/3 is a whole number. That should be a z. All right, here we go. I'm going to have the 2 here, and then I'm going to have those that are still cube roots, the cube root of 10. So 6/3 is the same as x to the 2nd. X to the 1/3, that stays at x to the unwritten down 1/3. You certainly could write it, but x to the 1/3 like that. 9 over 3 for the y is a regular 3. Y to the regular 3. Y to the 1/3 is y And we usually don't write down the 1/3. And 15/3 is regular 5, z to the regular 5. Can you do one more recording? I wish I could record that you're here, but we're not supposed to record students. Okay.